Bourns is pleased to announce the release of a new Thermally Protected MOV TPMOV surge protective device, the Model 1220 series, which will significantly expand our current product line offering. The Model 1220 TPMOV SPD was designed to safeguard electronics and electrical systems from voltage surges and transients. The SPD does this by absorbing excess energy during surge events and diverting it away from sensitive equipment. Its standout feature, the Advanced Thermal Disconnector, TD+, provides an additional layer of protection by allowing the SPD to disconnect from the power supply when necessary, improving safety and reducing the risk of overheating and fire hazards during prolonged surge events up to rated limits. These features help ensure the integrity of electronic systems and enhance overall safety through the use of the thermal disconnector. Additionally, this surge protection solution provides high reliability and space efficiency, making it an ideal choice for applications with limited space. Surge protective devices, or SPDs, play a crucial role in safeguarding equipment and ensuring overall electrical safety. By diverting excess voltage and current away from sensitive devices, SPDs prevent damage that could lead to equipment malfunctions or data loss. And by protecting the equipment, SPDs also enhance personal safety by reducing the risk of electrical fires and injuries. Moreover, installing SPDs directly translates to cost savings, as they reduce the need for expensive repairs and replacements necessitated by surge-related damage. In commercial and industrial contexts, SPDs uphold business continuity by averting downtime caused by equipment failures. From shielding against diverse transient sources to fostering uninterrupted operations, SPDs prove indispensable in fortifying electrical systems. Transient surges, which pose a significant threat to electrical systems, can arise from a range of sources. Internal load switching, characterized by sudden load variations, can trigger abrupt changes in current flow and create transient surges. The impact of lightning strikes, whether direct or indirect, can extend several miles from the strike point as a transient surge, causing disturbances or damage to installations. Additionally, the act of switching transformers, motors, and other inductive elements, coupled with load variations and circuit breaker operations, introduces transient surges in the form of overvoltages that permeate buildings. Notably, a substantial portion of transient surges originate internally. A comprehensive understanding of these diverse origins is indispensable for effectively mitigating the potentially detrimental effects of transient surges on electrical systems. The fundamental principle of a surge protective device is to limit the voltage that is applied to electrical equipment and systems to a safe level during transient overvoltage events. As such, SPDs are typically installed at the point where electrical power enters a building or facility, such as at the main distribution panel or subpanels. They can also be installed at specific equipment locations to provide localized protection. SPDs contain one or more surge protection components, such as metal oxide varistors, MOVs, and gas discharge tubes, GDTs. SPDs with MOVs are often designed with fail-safe features. In the event of a catastrophic surge that exceeds the MOV's capacity, the SPD disconnects the MOV from the circuit, preventing the surge from propagating further. In a three-phase 277 VAC electrical power system, the ideal TPMOV surge protective device model would be the 1220-I4-XXXM2 series for each phase. To ensure suitable protection, the voltage rating of the SPD, represented by its maximum continuous operating voltage, MCOV, should be set higher than the system voltage. A 15% margin is typically recommended, and in the case of a three-phase 277 VAC electrical power system, the suitable candidate is a 1220-I4-277M2, which leads to an MCOV rating of 320V. The surge current capacity, designated as IN, IMAX, and IIMP, should be determined based on surge protection requirements. As compliance with industry standards is vital in a protective device like this, The Bourns Model 1220 SPD meets the requirements for UL 1449. Two critical parameters are the protection level, often denoted as the voltage protection rating, VPR, and ensuring that the voltage across the SPD is lower than the equipment's withstand voltage. Surge protective devices offer versatile applications across various sectors. In commercial buildings, SPDs often safeguard sensitive electronic equipment such as servers, where they avert damage from transient voltage surges. Industrial applications rely on SPDs to protect equipment like motors, ensuring uninterrupted operation and helping to extend their lifespan. Telecommunications systems, including cell towers, benefit from an SPD's ability to shield against disruptive voltage spikes. Transportation systems from railways to traffic control utilize SPDs to prevent disturbances and damage. In renewable energy setups, SPDs play a pivotal role in safeguarding critical components like solar panels and wind turbines, ensuring equipment integrity and optimal energy generation. The Model 1220 series is a highly reliable surge protection solution, conforming to rigorous UL 1449 and IEC EN 61643-11 standards. It holds UL recognition as a Type 4, Type 2 location SPD and boasts a substantial 200 kA short-circuit current rating, SECR. Equipped with a dependable metal oxide varistor, MOV, that incorporates an advanced thermal disconnector, TD+, it ensures top-tier safety and protection. This innovative design replaces traditional MOV components and is gaining popularity in the electronic and electrical industry, including the surge protection device, SPD, sector. Its PCB-mountable design works seamlessly with reflow and wave soldering processes, and its compact size saves installation space. The Model 1220 TPMOV SPD series offers an extensive range of surge protective devices to ensure comprehensive protection for various applications. Each device is designated by its unique model designator, making selection easy. These devices feature a choice of 10 kA and 20 kA nominal discharge current, INOM rate options, allowing users to tailor protection according to their specific requirements. With max discharge current, IMAX options ranging from 22 kA to 75 kA, the Model 1220 TPMOV SPD series provides reliable protection against a variety of surge magnitudes up to rated limits. Users can select the appropriate operating voltage based on their system's requirements, with choices like 120 over 240V, 220 over 380V, and more. Furthermore, these devices are available in different module types, M1 to M4, allowing for easy integration into various systems. To order a product from the Model 1220 series, you can follow the simple naming conventions for these thermally protected metal oxide varistors. First, select the model designator 1220 to specify the product family. Then, choose the nominal discharge current, INOM, that matches your protection requirements. Next, determine the max discharge current, IMAX, suitable for your application, and specify the operating voltage according to your system's needs. Finally, indicate the module type from the options presented here. This ordering process ensures you receive the right Model 1220 TPMOV SPD tailored to your specific surge protection needs. The surge protective device can encounter failure modes that result in thermal runaway, potentially leading to overheating, smoke emission, and even the risk of fire. These failure modes include end of life. As an SPD nears the end of its operational lifespan, it becomes less effective at mitigating surge events, potentially allowing damaging surges to propagate throughout the system. Sustained abnormal overvoltage, or TOV. Extended exposure to abnormal voltage levels beyond the SPD's capacity can push it into thermal runaway, causing overheating and compromising its protective capabilities. Surge with unexpected energy. A surge event that carries energy beyond the SPD's design parameters can overwhelm its protective components, triggering thermal runaway and associated hazards. The significance of the TD+ Advanced Thermal Disconnector in surge protective devices lies in its ability to employ fail-safe and self-protection mechanisms, even in challenging scenarios. With TD Plus technology, an SPD remains secure and reliable, even if the temporary overvoltage, TOV, reaches twice the maximum continuous operating voltage, MCOV. This technology's mechanical structure enables a permanent and secure disconnection from the power system. It not only prevents the SPD from overheating and entering thermal runaway, but also interrupts AC arcs and short circuits, mitigating the risk of fire hazards. By offering enhanced safety measures and greater resilience, TD Plus technology significantly elevates the reliability and effectiveness of SPDs, making them a crucial component in safeguarding electrical systems and equipment. For more information on Bourns Model 1220 TPMOV SPD, check out our additional available resources through these helpful links.